This is Unit 11, Acids and Bases. Lesson 4, Titrations. How is the concentration of an unknown acid or base determined? The objectives of this lesson: I can determine the products of a neutralization reaction. I can calculate the unknown concentration of an acid or base using the titration formula. I can calculate the unknown concentration of an acid or base that yields more than one hydrogen ion or hydroxide ion using the titration formula. Do now. So neutralization, as a quick refresher, is when an acid and a base react to form water and a salt, which makes a neutral solution. Therefore, that's why we call it neutralization. So the hydrogen ion of the acid and the OH hydroxide ion of the base combine to form water. The anion of the acid and the cation of the base come together to form a salt. So this is what happens in your stomach when you have a stomach ache. You have excess stomach acid in your tummy, and then you add some Tums, which is a base, and together they neutralize that acid, forming a salt and water. So to complete a neutralization reaction, the H plus and the OH combine to make water, and the leftover metal and non-metal combine to form a salt. Don't forget to balance your reaction once you're done. So for example, when I add HCl plus NaOH, our acid and the base, together, the H from the acid and the OH from the base combine to form H2O. And what's left over, the Na, which is positive, and the Cl, which is minus, combine together to make our sodium chloride. Remember, always write the metal first. So for example, the way this is done, you take the H from the acid, you take the OH from the base, and that makes your water, H2O. What's left over, my potassium is plus, my bromide is minus. Together they make potassium bromide. Always write the metal first. So you try one practice. I'll go over this in class. Okay, the acid-base titration. This is the controlled process of acid-base neutralization. We do this to determine the unknown concentration of an acid or a base. And it looks like this. We have a flask at the bottom filled with acid and an indicator. And in the top, we have our base with a burette. And what we do is we gradually drop the base into the acid until we reach neutralization, and then we measure that volume. So in a titration, the endpoint is with a pH at which an indicator that has been added to the titration setup turns a color. Therefore, we've reached neutralization. We now have a neutral, I spelled neutral wrong. We have a neutral solution. This is when the moles of the hydrogen ion are equal to the moles of the hydroxide ion. So this is your definition here. So what a titration looks like, we're going to do one in class, but here's a picture so that you have an idea. This is a flask containing an aqueous solution of a sample being analyzed, so that's either an acid or a base. Then we have a burette, which are usually 50 mils, containing the sodium hydroxide. So in this case, the acid will be in the bottom. Then the sodium hydroxide is dropped into here, and notice we get that color change. And we will continue adding sodium hydroxide until the color remains a different color. And that's how we know that we've reached neutralization, or the endpoint. Then we will take the volume of our base and determine the concentration of our acid. So to solve titration problems, you'll use the titration formula from table T. So it's the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. And all of that stuff is given to you in the titration formula on table T. So for example, what is the concentration of a solution of HI? This is our acid. If 0.3 liters is neutralized by 0.6 liters of 0.2 molar solution of KOH. This is our base. So we have to be able to identify our acid and our base so that we can use the formula correctly. So we'll use our formula Ma, Va, equals Mub, Vub. So we're looking for the concentration, which is the molarity of our acid. So we're looking for the molarity of our acid. We'll multiply it by 0.3 liters. That's equal to the molarity of our base, which is 0.2 molar, times the volume of our base, which is 0.6 liters. We'll do that quick calculation. Let me grab my calculator out of my bag here. Where are you, calculator? Seriously. We'll take 0.2 times 0.6, which is equal to 0.12. So our Ma is equal to 0.12 divided by 0.3 divided by 0.3 is equal to 0.4 molar HI. All right, sorry, I'm shaking this. All right, one more example. What is the molarity of NaOH if 100 mils of 3 molar HCl is titrated with 200 milliliters of NaOH? So here is our base. Here is our acid. So we have the molarity of our acid, which is 3.0 molar, times the volume, which is 100 milliliters. We want to know the molarity of our base if we have 200 milliliters of it. So we'll take 3 times 100 and divide by 200. So 300 divided by 200 will be 1.5. So the molarity of our base is equal to 1.5 molar NaOH. All right. One more example. What is the molarity of 100 mils of HCl if it is neutralized by 250 mils of 2 molar NaOH? Here is our acid. Here is our base. So we need to know the molarity of our acid if we have 100 milliliters is equal to the molarity of our base times 250 milliliters. So divide by 100. Divide by 100. The molarity of our acid is equal to 2 times 250, which is 500, divided by 100, which is 5. So we have 5 molar HCl. So there is one exception. The titration formula only works if the acid and base have equal numbers of hydrogen ion and OH ion. If not, the acid side must be multiplied by the number of hydrogen ions, and the base side must be multiplied by the number of hydroxide ions in the formula. So what we would get is a modification of our formula where we would multiply the whole acid side by the number of H's and the whole hydroxide base side by the number of hydroxide ions. So for example, if you have 50 mils of 1 molar H2SO4, what volume of 0.5 molar NaOH would be required to neutralize the acid? So remember, diprotic acids yield 2 hydrogens in solution, so multiply by 2. So here is my diprotic acid. So I would follow the same formula, except I would multiply the acid side by 2. So it would be 2 times our 1 molar acid times 50 milliliters is equal to the 0.5 molar base times the volume, which is what we're looking for. So that what I would get is 50 times 1 times 2 divided by 0.5 equals 200 milliliters. All right, so you try this example on your own, and I will go over it in class. And now check your understanding. And now you can determine the products of a neutralization reaction. You can calculate the unknown concentration of an acid or base using the titration formula, and you can calculate the unknown concentration of an acid or base that yields more than one hydrogen ion or hydroxide ion using the titration formula.